Next, we'll talk about web application hacking. Our objectives: discuss web application attacks, perform web application attacks. What we love about web applications is, from the red teaming standpoint, we know there's going to be web servers available publicly. There have to be. So because of that, we look at web application attacks as one of our usually pretty successful means of breaking into an environment. So what happened is the database evolution. So we have all these actual flat file hierarchical 3-tier databases, and to add a web servers was the nth tier. So now we have all these web servers that are usually front ends for back end databases. So the web application itself running on the front end is usually the protection for the back end database. And what we have found is programmers traditionally do not do a good job of filtering their input, and it gets to the back end database. Depending on the type of database that is, this can lead to compromise. And it's all based on what we call input validation. This is accepting input, the length, the type, the range, the source. We have to validate the input and validate it's valid. Remember, all machines are at a binary level. So if we send input in and we obfuscate it in such a way and the front-end writer doesn't look at it, we've bypassed the front-end writer's protections and made it to the back-end database. Cross-site scripting is one of the most common type of attacks that we have is cross-site scripting. What that is that's getting the actual trusted server to manipulate it to redirect it to another site. If you remember from one of the previous sections, we talked about the malicious code, the client-side attacks, and a rogue server. That's exactly what cross-site scripting is. You think you're talking to a trusted server, but you've been cross-sited to another rogue server. Then we have SQL injection and any code injections, HTML injection, those types of things. SQL injection is available because if the input filter, the front end, allows commands to go to the back end database, say enter your username, but instead of entering your username, you enter single quote or 1 = 1 -- which is the most common SQL injection we like to use. That will allow the back end database to dump all the records of the database if the front end doesn't properly sanitize input. And then we got buffer overflows. We've already discussed buffer overflows. So cross-site scripting, we've got two types. We have stored, which is persistent, and we're reflected, which is non-persistent, which usually requires some form of social engineering or phishing. That means click here and go to this site. The basic signature there, as it shows you, is a script tag with an alert box with a closing script tag. And what it is if I put this script tag in and I sign it, and it gets interpreted, the script tag does, by the HTML engine, that means the front-end writer did not properly sanitize input, and therefore cross-site scripting is possible. And then what I do is, inside this alert tab, I can put in document.cookie, which is still the actual cookie from the machine. I can put an actual href back to a rogue site and append the actual cookies to that request, send it to me. So there's a lot of things I can do once I identify proper input validation is not happening. And then, of course, we can do IDS evasion using other encoding. We've talked about we can do obfuscation. We can do what we call overlap. We can do underlap. We can do a lot of different ways to do cross-site scripting. Once we get input validation vulnerability, the sky's the limit. And this is an example of what it looks like a cross-site scripting on the National Vulnerability Database. So if you look here, we're showing you cross-site script vulnerabilities in PHP. One of the most common ones are against PHP targets and stuff like that. So what happens is somebody sets up a web server, puts on a PHP application, and don't realize the PHP application itself has a cross-site scripting vulnerability. If we get a user to click on a link and they're on that web server that has that cross-site scripting PHP vulnerability, that link now will redirect to our rogue site. Then we got SQL injection, and this is another look at the National Vulnerability Database of SQL injection to show you how prevalent it is. SQL injection is mainly single quote or 1 = 1 -- because it says if either or statement's true, execute. The -- in SQL means treat the rest as a comment. So if you have a username and a password field, the username single quote or 1 = 1 -- results in a true statement. -- says treat the rest as a comment, and guess what? We get to the back-end database, 1 = 1's true, username true, dump all the records of the database. This works. Remember our scope of work. If you don't have authorization, this is malicious. So only do this if you have written authorization to perform the test. Because if you do it more than likely it'll work because we continue to see prevalent cross-site scripting and SQL injections on the internet. The best way to learn web application hacking is tutorials. You have to go practice web application code because we've got regular testing, we've been talking about those types of things, or methodology. Web applications are code. So depending on how the person wrote the code, you have to know that, or at least have an idea of that, to be able to perform an attack. So we've got WebGoat from the Open Web Application Security Project group. It's a lot of lessons in there to learn. We actually do an exercise on that. It's actually a very good tool in a tutorial. For those of you who find WebGoat a little bit code, a little bit too much, Mutiliday from the Iron Geek site has a lot of information. It's less code knowledge required than WebGoat, and he has all kinds of videos and all kinds of cool stuff you can do there. So again, tutorials, practice, practice, practice is the only way to get good at web application testing. Mutiliday, this is a picture of Mutiliday. See, it's got cross-site scripting, injection flaws, all these different types of techniques of practicing, and it usually goes with the Open Web Application Security Project top 10. It will have the same top 10 security flaws as lessons. And now we're going to do a lab attacking web apps.